So guys, attendance is open already. You can mark it. They would have been a class, right, from 9 to 10? Okay, I'm just like waiting for a few more people to come up. Did the 9 to 10 class end late? Because I only have 54 people till now. Okay, looks like we are not going to have a good attendance today. So I guess we can start. Okay, so today we are going to talk about the lecture 8.3, that is on data structures basics. Basically two data structures, stack and queue. We will have uh, another look at one more data structure in the next week, and that is linked list. But right now we are just having a look at stack and queue. And the term stack, for example, we have used multiple times during our discussions. It's just that I've never really told you what a stack is. So now this is the time when we actually discuss what exactly is a stack. Okay, so I need volunteers. Okay, Pranav, just a minute. Pranav and Arunim, just a minute. Guys, your section and roll number.
AI 10.
CS25.
AI 10, CS25, 25. Got it. Okay. Uh, any more volunteers? Mm, I would like at least one more. Three should be a good number. No? Then otherwise, yeah, Karishma, sure. Tell me your roll number and section.
CS29.
CS29. D9. Got it. Okay. Fine. So I think three are fine. So let's start, guys. My screen now.
Yes, it's visible.
Okay. Okay. So I'll mute myself.
Okay, so first question is explain in brief the process of a function call. Would any of you guys like to take this one? Okay, I'll try. So basically, when you call a function, um, it uses the stack. I hope you guys have went through the lecture and know what a stack is. If not, I'll just give a brief description. Stack is basically like a literally stack of books. You take one book from the top, you can put one book on the top. It's basically like yeah, like a stack would behave in normal life. Instead of books, it's data, like some integers or some characters or something like that. Yeah. So when you call a function, the first thing that happens is you put local, all the variables of your current function, all the local variables of the current function on the stack. Then you put the address of the current function on the stack so that it knows where it has to return to. Finally, you put the variables which are uh, parameters to the function which you're calling on the stack. So for example, if you're calling int sum, then you will put two integers a and b on the stack after the return address. So after this is there, then the CPU jumps to the address of the function which we are calling. Basically, in memory, these two are at different locations. Maybe one is at, let's say, some 1,000 bytes away from other. So the CPU moves its execution to that another point. So after another point, like normal execution happens, like we have discussed so far. At the end of the uh, execution, it has basically removed all the local variables from the stack, as not the local all the parameters from the stack. So and acted on it and whatever. Now it has to return something. So the return, and it has to return to the calling function. For example, if we are calling int sum from main function, so it has to return to the main function. So it checks the stack. As I said, the stack has the return address of the main function. So it takes that address and jumps to that address which is on the stack. And yeah, so this is how a function is called.
So,
Any questions?
if you guys want, I can also share the same slides that we have used in that I have used. I mean, in the lecture. But the idea is that you should have an idea of what happens when a function is called. That is the only thing, and this is not something that is specific to C. Okay, function calls are implemented like this in, I think, almost all the languages. Okay, so it is the same concept. So the slides that are there, they are there to actually tell you how function calls happen. Okay, so let's now if you guys have any queries, let's start with it.
Okay, while you guys come up with your questions, would one of you guys try to take the second question?
Yes. So in second question, there are three functions, f1, f2, and f3. So f1 calls f2 and f2 calls f3. So we have to say about the time of the local variable reside in the main memory. So when f1 calls f2, so it's like a stack, as Pranav already told. So the function f1, the space for the function f1 is at the bottom of the stack. So uh, when the f1 calls f2, so the space for f2 is created above the f1. So when f1 calls f2 and f2 calls f3, so after the execution of all the functions, so the time is taken for all the functions f1, f2, and f3, the total time.
Okay, so I don't think that answered the question, so I'll just continue from there. So when F1 calls F2, as I explained, all the local variables inside all the local variables from F1 are pushed on the stack, followed by the address of F1. Then we start executing F2. When F2 calls F3, all the local variables are pushed on the stack and we go to F3. So after F3 does its thing, its local variables it returns. After the return statement, as we know, it the local variables go out of scope and are destroyed. So in the first F3's local variables are destroyed. After that, F2 returns and the local variables of F2 are destroyed. After this, F1 returns, or maybe what F1 continues execution. So F1's local variables are destroyed in the end. So in this case, the time of variables inside local memory is maximum for F1, minimum for F3, and F2 is between F1 and F3. Any questions?
So just a very simple thing. Like, I mean, I feel like most of you probably have not seen the lecture because I was expecting so many questions in this lecture. Or maybe it is a very, very good lecture that there are no doubts at all, right? Which seems highly unlikely. Anyhow, so the idea is that you have to just understand this whole process, because if you understand this process, right, and how exactly uh, a particular function calls chain work, then you can understand so many things about pointers. Okay, so why is it that it becomes difficult to return a pointer from a particular function? Why? Because if it was a local variable and it has been removed from the stack, you are actually passing an address that no longer contains the expected variable, right? So this, and similarly, this is why while you can pass anything from the calling function to the called function, because the memory of the calling function is still intact within the main memory. um, it doesn't work the other way around, right? uh, the functions that are later in the chain, so if I say f1, f2, and f3, um, f3 will be on the top of the stack, f1 will be at the bottom of the stack. Okay, so uh, memory, yeah, that is the idea, right? So Karthik, that basically this is the problem, that whatever gets allocated on the stack, it will be removed as soon as the function returns, right? So even if you want to send something by return something by reference, it will not work, because that memory location itself, provided that it was a local variable, that memory location no longer exists. Okay, it has been cleared. So I just want you guys to understand this whole chain, right? And because this is not just in C, this is in all the languages. This is exactly how function calls are implemented in languages. Okay, that you put the current function, the memory of the current function on, let us say, which was currently on the top, something else comes on the top. That is the idea. Okay, and that is the use of stack. We've been saying the word stack for a long time, but this is the actual use of stack. Okay, this is a paradigm. This is not something that is uh, explicitly applicable to C. Okay, yeah, go
Sir,
ahead.
in the
Yeah.
code you have given in the lecture, like
Yeah.
we define f1 function afterwards and use it beforewards. So how
Ah,
it is not giving an error?
ha ha ha.
I don't
Sorry, sorry.
understand that particular thing.
So yeah, sorry. That must be an error. Because I was not really looking at those aspects. You are right. Then it will be an error. The idea was just to show you some example, and I had very limited space, because I had to create a slide, and if I added any more lines of code, it would have taken up more space in the image. So probably that is why I forgot to add the declarations. But yeah, declarations are required. Either I should push f1, f2, f3, everything above the main, or
Yes, sir.
sorry for that. I'll just add it as a note on the lecture in YouTube as well. But yes, this is right, that technically this is not the correct thing to do, but I was just trying to show you some concepts, something related to. But yes, declarations are required in this case.
Okay, sir. Thank you.
Or instead of declarations, you could put prototypes before main function and declarations afterwards.
Yeah, so prototype, Pranav, is a kind of a declaration actually.
Yeah,
Uh,
yeah. I don't think we discussed those, right? That's why I brought it up.
uh, I think it's there in the slides on functions. I have said that basically prototype is a specific type of declaration. Declarations can be vague also. Prototype is probably the
Yeah.
best type of declaration, where you provide all the information. Uh, yeah. So yeah, sorry. Uh, so guys, I hope this part is clear. The concept of a function call, that what really happens. And once you understand the concept of a function call, then it is very easy to understand what is stack. Okay, in fact, sometimes people do it the other way around. They'll teach you stack first, and then they'll tell you this is how function calls are implemented. I have done it in the opposite fashion, because we've been talking about function calls recently. So I thought, let me just tell you how function calls work, and then I'll tell you this is what stack looks like. Okay, so, go ahead, guys.
Okay, then I'll start with the third question. Whatever goes in first in a stack comes out the last. As we have already seen that a stack can be compared to a tumbler, so it is open only at one end. So whatever you're going to put and whatever you're going to remove is only through one end. So if you're putting something very first, then it will stack one above the other. So the thing which will remove from the tumbler, one by one, from the top it will be removed. So the first thing you put inside will be the last thing you can remove.
Yeah, so this is basically like last in, first out concept. Like another name for this is last in, first out, LIFO. Any questions?
Okay. So any more doubts on this?
So I will move to the next if there is no more doubt. Uh, so the top variable points in a stack, the element which is pushed, we have just pushed into the stack, or we have just inserted into the stack the top element.
So you understand that why you need only one variable for a stack? Because at any point of time you are just you just care about what is on the top. Okay, you don't really need to check what is there below. Okay, in some ways it's like this, that the tumbler example, if you are putting, let us say, biscuits in a tumbler, only the topmost biscuit is available to be taken out. Whatever is down, it's possible that there is some other biscuit below that biscuit, but that is not accessible to you. It's only the topmost biscuit, right? So it's similarly, the only element that is kind of accessible to you is the topmost element. Nothing below that is kind of accessible to you. It's like this. Okay, does that make sense? And shall we move ahead? If there are any queries, please ask. Okay, I guess you can move ahead then.
So the fifth question, whatever goes in first in a queue comes out. As we have already seen that a stack is compared to a tumbler, I may suggest that a queue can be compared to a pipe, which is open at both the ends. But the restriction here is one side is open to be entered and the other side is for the exit thing. So the whatever goes in first comes out the first. It is right opposite of stack. Is it clear?
Yeah, please repeat it.
Okay. So as I earlier said that stack is compared to a tumbler. I say that queue can be compared to a pipe. So it where both the ends are operated. One side is open for entry and the another is for the exit. So one side you put keep on putting things and the other side is for the removal of the things. So the first thing you put it will be the first thing which will come out.
Yeah, I'll just give another analogy. A queue is, as the name suggests, a queue. So it's like a line in front of a roller coaster in a theme park or something like that. So whoever joins the line first leaves the line before the guy who joined after him. So if you joined the line before me, you will leave the line before me. So yeah, so this is like first in, first out. FIFO, yeah. Any questions, or we'll move to sixth?
So guys, like you understand the difference now between a stack and a queue? That stack basically is a one-ended data structure, and no, vector is more like a that is just the kind of uh,
Linked list.
multiple sized array. You can consider a vector to be a multiple sized array, right? You can access any element of the vector at any point of time, right? It's like this. um, it's not even a linked list, to be honest. A linked list will mean that you should access it in a sequential fashion, that if you want to access the fourth element, you should start from the first element and then move up to the fourth element. A vector is mostly like a variable sized array. That is the idea. Okay. Uh, the equivalent of a vector in Java is array list, actually. Okay, list or array list or whatever you call it. So yeah, so vectors are not really the same as stack. It's like this: you can use a vector to emulate a stack. That you can do. In fact, what we are doing in that example is we are using an array to emulate a stack. Okay. The idea is that you have to restrict the operations. Okay. So from the basic operations of array that we have already studied, there were only two, right? Insertion and deletion. Now the same operations, insertions and deletions, if you actually restrict the position at which insertion and deletion can be done, then you can come up with a new data structure. So that is what stack does. So in stack you can always there's only like one end of the array. You cannot insert anything in the middle. So you can only insert something at the end, and you can only delete something from the end. If there is an array like this, it is behaving like a stack. Similarly, if you have an array where insertions happen at one end towards the the end of the array, and the deletions can only happen at the front of the array, then you are essentially emulating a queue. Okay, so queue is a two-ended data structure, bi-ended, whatever you call it, and stack is a single-ended data structure. Okay. So yeah, if there are any queries, please ask. Otherwise, you can move ahead.
Okay, I'll just take the sixth question. What do the rear and front variable point to in a queue? So the front variable points to the element which was inserted first or inserted before all others, and the rear points to the variable which was inserted last or after all other variables which are already in the queue. So in case of the people in a roller coaster line analogy. So if you join the queue before me and we are only the two people in the line, so you will have the front pointer and I'll have the rear pointer. Yeah, any questions or
Can you hear?
Yeah, go ahead.
yeah, Rajesh.
Sir, the thing is, the insertion and deletion operations in stack or queue, we are not actually deleting it. We are just moving the pointer forward and backward.
Yes. So
Sir,
that is the
so
idea. See,
is it?
deletion, yeah. Even here, what happens is, whenever I say I have removed something from the top of the stack, or I have removed something from the front of the queue, basically I'm just forwarding a pointer. That is the idea, right? In fact, this is something that we've had a discussion over multiple times. This is a common thing in computer science. Whenever you even delete a file from your hard drive, it's not like the file is actually deleted. Okay, it's just that there were some pointers in the memory which were telling me that this file resides on these blocks in your on your hard drive. It's just that I delete those pointers, so there is no way now to retrieve the file. Okay, in fact, this is why there are some tools which can go through your hard drive and retrieve deleted files. Okay, this is how they do it, because there is really no actual deletion. The deletion is of these
Sir,
pointers and metadata.
sir, actually, my point was actually override that memory, but here the memory is already allocated. I made the array
Hmm.
override it. We know that we are moving the pointers forward and backward, but
Hmm.
unused
You're talking
that unused part
you're
we
talking
cannot
about
actually
queue or
override
stack?
it.
You're talking about queue or
Sir, I'm
stack?
talking about sir,
Talking
queue and stack both.
Sir, see, in stack you can overwrite it. Why? Because let us say, in fact, let me just open up that slide. uh, mm, in stack you can overwrite. In queue, yes, you cannot overwrite unless it is a just a minute, let me open that slide once. Huh. Okay, let me share this one. Hmm. Can you guys now see the slides? You can, right?
Yeah.
Okay. So let us assume this is what my stack looks like. Okay. Let me use this laser pointer. Where is it? Laser pointer. Huh. So let us say this is my stack in the beginning. There is just one element called 12, right? And when I say push, what happens? 21 gets added here, right? So this is the end where I am. This is where my top is, right? And at this end of my array. So currently top is here. When I push it, top goes here. I push another element, the top goes here, right? Now when I do a pop, what happens? 39 again. 39 gets ignored, right? So I'm just making top go here. So essentially 39 is still here, but my top now points here. And then when I do another pop, okay, the 21 also goes off. So my top is here. So 21 and 39 are still here, but they have not yet been overwritten. But when I do another push, I do 43, then 43 gets written here, and now 21 has been overwritten. Okay, if I do
Sir,
another push, yeah,
sir,
go
by
ahead.
overwritten, I mean, suppose I'm making some other call. I mean, so, I have some other function which requires memory,
Mhm.
but the memory has already been occupied by this stack.
Yes. So that is the
That
idea.
that
The
is not
overwritten.
segmentation
Yeah,
problem, na?
right. See, it's like this. Deletion of the array itself from the memory, that too will happen at some point of time. So that is what we call as freeing up of the memory. And this concept is applicable when we talk about this. Let me show you this example, then you will understand. So in this case, I have this function f1, right? So let me go back a little further. Ah, So at this point, we are here, right? Where does the F1 function start? Okay. Yes. So when I called F1, some memory was allocated in the main memory here, right? And now all the local variables in F1, here I have just shown one. There may be others also. They'll be allocated some memory in this range, in this block. Now, as soon as I call F2, something will come and sit on top of this memory. So this memory is still there. I have allocated some new memory. When F2 returns, what happens? This memory gets deallocated. So now assume at this point there was some memory in so there were some variables in F2, even though I did not have any variables here, but there must have been some, if there were some local variables in F2, because I said this space has been freed. Again, it means the same. It's not like the memory locations here will be overwritten. It's just that the stack pointer will come down, it will come here. Okay, and we will assume that this memory is free now. And now what happens when I call F3? Most probably F3 will come and sit on top of here only. So now the memory that was being allocated to F2, it gets overwritten by memory allocated to F3. Now coming back to your question, you are saying that for an array it is not really freed. Yes, it is not freed. That is the idea. But when I say deleted, you have to understand that deletion and insertion is an operation that is applicable to the user and not the machine. You understand? For the machine, the operation is freeing of memory. Insertion and deletion are user level operations, right? So it's like this. At any point of time, user can ask me, like Pranav has given an example, that let us say I am trying to maintain a queue where um, I'm going to give people some token that, okay, as soon as you enter the queue, I am going to give you this token, and you have to wait for your turn, and when you are done, you will go out of the queue. Similar to how we do on a, let us say, on a railway station. We go and stand at the rear of the queue. People keep on uh, exiting from the front, and when I reach the counter, I get my work done. So now, where exactly let us say if I want to create some program where I'm writing the name of the person that is joining the queue, how will I do that? I'll use some basic variables, right? I'll probably use an array. For example, I'll create an array of assume, let us say, the amount of people that can stand in the queue is only 20. Okay, I don't have more space in my railway reservation room, right? So there can only be 20 people in the line at any point of time. So I create an array of 20. Okay, and then what I say is, whenever whenever you come in, you just get a position in this array, and whenever you go out, your position is cleared, as in now someone else can come and stand at your position. So the same concept is here. When I say deletion from array, it means that this particular element is now ready to be this particular index is now ready to be occupied by some other value. Ready, it doesn't mean that it has already occupied, but ready. I can actually occupy some other value can come and occupy it at a later time. Similar to this case where I said when I freed this memory, it did not mean that this memory has been overwritten. But if I have a function call right next to this, there is a good chance that this function call will be allocated the same memory that was allocated for the previous function f2. Okay, so now it's like this. I just mark a particular memory location as available. That is the idea. It doesn't necessarily mean that it has been overwritten. It is available. Okay, and the same thing applies with an array. When I say I have deleted a value, it means that I no longer consider it to be a part of my data. Okay, so that location is in theory available to store some other data. That is the only concept that I'm saying for. It is true for deletion, and it is true for stacks and
So,
queues, everything. Yeah, go ahead.
so what is the difference between queue and vector then? Means we can access any element from queue as well. So what is the difference between
Uh,
queue and vector?
no, ideally you cannot access any element from a queue. You can only access the element at front. and you can only add an element from the rear. Okay, when I say access, see, you have to understand, it's about the data, it's about the implementation, right? Because I'm implementing it with the help of an array. Yes, you can always write arri and you can access the ith element, but
Yes, ma'am.
when
Yes, sir.
yeah, so that is the idea, that this is because the underlying property, the underlying variables that you are using to implement stack or queue, they allow you random access. But let us say we once we have read what are linked lists, then you will understand that it is possible that your stack or your queue has been implemented in such a way that doing something like ARRI is not possible at all. Okay, we will study what are linked lists, and many a times when you are having huge stacks, okay, huge stacks or huge queues, you don't implement them using arrays, you implement them using linked lists. And in a linked list you will only have access to either the top if it is a stack, or the front and rear variables if it is a queue. That's it, you cannot
Sir,
actually access. Yeah.
sir, they are all like five data structure which are almost the same, like stack, queue, vector, array, list. So, sir, can you tell me where and why we should use this? Means what is the fun of having so many data structures?
Okay, first of all, stack and queue are not the same as array and vector. So it's like this. Let me now stop sharing this. Shall I stop sharing this and go back to the word? Naveed, Naveed, did I answer your query? That basically,
Yes, yes,
uh, yeah, we are not really deleting it. We are simply saying this memory location is now available to store some other data. Okay, I may not do it immediately, but in future, if I need a space to store something, that memory location can be used. This is the idea. And again, as you said, that even though I'm not deallocating the array, the reason this is a more of a user level operation. I have been given for 20 locations by the compiler to store my data. I say that currently I have 5 elements in my data, so 15 are available. I can store 15 more data items. And if I say I have deleted one, it means now I can store 16 more data items. 16 new data items can be stored. So that is a notion, that is an idea that I have deleted something. Okay? So I'll just
at
go
least,
back.
sir, my point was uh, most of the operations we do using arrays. I
Mhm.
mean, they are at the end of the day memory inefficient.
No, it's not like that, that most of the operations we do are using arrays. In fact, uh, as you'll study more and more, you'll understand that arrays have their own limitations. Okay. So usually for when we do these stack and queue and other implementations, we use of linked lists is a very common thing. Okay. And
Yes,
linked
sir.
lists will, right. So yeah, stacks and arrays are used for cases where the data is very small, or the data elements are not too huge. When the data elements become huge, we don't really use array, we use linked list. Okay. So yeah, so I mean, you'll get to understand the importance of linked list as you study more computer science. That is the idea.
Mm.
Sir,
Okay.
sir,
Sorry, so I had one question. I actually lost it. So we were about vectors and arrays, right? So it's something like this, guys. Let me share the file again. Okay. So the first thing you have to understand is stack queue. Let me just put some space, and linked list. There are some others as well. Let me tell you what they are. There is a no, there are trees. Okay, you'll study trees, and then there are graphs, and there are
Sets.
many more. Right? Go ahead.
So sets is really commonly used.
Yeah. Okay. Sets. So I don't know exactly what all things you guys already know. Okay, I'm just saying that. So these are all data structures. Okay. Now the only thing that is common here, okay, basically, and what happens is something like this. This is like one layer. Now, in order to implement this, you need some variables because uh, you know you don't get stack as a direct variable as a data type in C, right? It's not like you can create something like stack C or stack S or QC or QS, right? So you actually have to implement it using some basic data types that you have been provided by your language. I'm not saying all languages are like that. No, there may be certain languages where stack and queue are basic data types as well. But let us say in a language like C, they are not provided to you by default. So you have to implement them. And how do you implement them? You implement them with things like arrays, um, vectors. Okay, linked list. It is basically, it should ideally be here and not here. Uh, so it should be actually here, right? So you implement them using linked list. So what are they? They are um, collections of data types. Okay, so array is a collection of the same data type, and if you remember, structures are collections of different data types. So basically you use these data types to implement these. So that is, do you understand that basically they are at two different levels? So when you say why do I need stack, queue, and array all together, it's because they are arrays and vectors are at a lower level. Okay, you can use arrays to actually implement stack and queue and tree and all these things. Does that answer your question?
Sir,
They are
can
at
you
two
just
different.
give me an example, sir,
Yeah,
for
of
this?
course. The example we have seen in the slides, right? I said you can use an array to emulate a stack or emulate a queue. And how exactly were we emulating? We were basically saying there is an array, and if I make sure that the insertions only occur at the end, then you can use it like a stack. Similarly, there is an array. The insertions occur only at one end and deletions occur only from the other end. It is a queue. Okay. So this is an example. There are ways to represent trees, graphs, sets, everything. There are ways in which you can represent them using an array. Okay. What is the best way to give you a non-computer science example? Um, okay. Let
Samaya.
us. Yeah. Go ahead.
Okay, so when you are, let's say, chatting with your friend on WhatsApp and your internet goes out, so basically, and let's say you send three messages. So you can think of these three messages as being put in a queue. So when your internet comes back, the first message is sent. After that, the second message is sent. After that, the third message is sent. So it's like a queue is basically the same thing, right? You put whatever you put in it first is removed from it first. So when your internet comes back, the first message that you sent will be removed from it first and sent to your friend, then the second, then the third, then the fourth, and so on, so on, so on. Yeah. Do you want me to try to give examples for others as well?
Yes, yes, please, please.
Okay, so stack is, as we discussed, used a lot in function calls and stuff like that. So I hope
Yeah, I
that's
got that.
okay.
Please,
Yeah.
sir, I just want to know that why we should use P if we can use vectors everywhere
Okay. So
or array.
the need of vectors is for arrays. So if you don't know the size of your input, then using vectors is a really good idea, because if you let's say declare a size an array of size 10, but the user gave 11 elements, then you'll have to resize the array. But let's say you resize the array to 11, but then the user gave one more element, then you resize it to 12, one more element, 13. So this resizing and copying from the previous array to new array is a really expensive operation. By expensive, I mean it takes a lot of time. So instead of that, when you use vectors or array lists, it is basically like arrays. I mean, we will study it in next semester, I think. So yeah, so this also under the hood, it does perform these operations like moving arrays and resizing arrays, but it is done in such a way that overall cost is same as if you are putting in a array of size infinite. So yeah, so that's vectors. Anything else? I hope you guys
Got
know
it.
graphs. If you appeared for like a maths Olympiad, like Maharashtra's RMO, Regional Maths Olympiad, so graphs are kind of one of the like some of the syllabus of that. Trees are commonly used for sorting and when you want to preserve some order in something. And so if you have a set of numbers the user is giving us and you want to sort them, what you could do is you could have an array and you could put it in the correct order. But if you have an array of 2, 5 and the user gives us 4, so you'll have to move 5 away. Uh, this in this case it is pretty easy, but if you had like an array of size 10,000 or something, then it becomes really difficult, really time consuming. As I said, moving things around is really not easy, really expensive. So in this case, using a tree like a binary tree or maybe some 2 3 trees or whatever, we'll study more. So in this case, using a tree will allow us to insert this element in really fast time. Like if you guys know big O notation, it's basically log n time. But yeah, that's not relevant. But basically, trees allow us really fast insertion and stuff like that. Sets are really special. They are like my favorite data structure. So sets allow you to insert elements out of order, but in constant time. So basically, if you have an array, imagine if you did not have to sort that array or whatever, but you just need to know if an element is there. So in traditional case, we will have to like look through every element of the array and then we'll find it or maybe we'll not find it. In case of sets, it is constant time. Like it will be equivalent to looking at just the first element, but that's I guess not.
Pranav, let's stop, right? Because I don't
Yeah,
think we all need to right, because some people may not be able to follow. So
yeah.
see, guys, the idea is that you are going to study data structures at depth. Okay, it's not. This is not really a subject where I should have talked about data structures. The only reason I included this lecture is because this function call thing, right? This is a programming concept. If you understand how function calls happen, so many of your doubts may actually get cleared. This is the only idea, right? Like for example, why do you get a warning if you try to return a value by reference? And you may have you may have seen this warning. You are trying to return something in stack or something like that. I think Karthik had an issue with it. uh, so you will understand the reasons for these warnings if you know the implementation from at the background, right? So probably I should have only talked about stacks. Okay, but then I thought that you'll have the same question, right? That why do I need a stack if I have an array where I can access everything? Why do I want to have an array where something is restricted to only one index, right? Why do I need it? So then I thought, okay, I should probably also tell you what is a linked list, because usually um, at higher levels stacks are implemented through linked lists and not arrays. So then I thought, because going to tell you about linked lists as well, why not also tell you about queue? But please keep this in mind, that if even if you don't understand this, it's fine, right? I mean, you'll anyhow study everything from scratch. You don't tell your data structures teacher that you've heard the terms stack, queue, and linked list. Okay, let that person teach you everything from scratch. But now, when you study, you'll at least know, some concepts of data structures. But all those things, right? Stack, queue, um, hash maps, sets, trees, all those things you are going to study. Okay, so don't be worried. Okay, you will study all these things. It's not necessary for you to understand everything today. The idea was just to give you a brief overview. So I have done that in the course, right? I have given you brief overview of your whole computer science journey. Okay, because in my view, this is the most important subject. Okay, if I can intrigue interest in your mind, um, your whole computer science journey will be pleasant. If I just restrict myself to teaching you C syntax, then you might not really be that interested in studying computer science. This is the idea. It happened with me when I was in at the 10 plus 2 level. My 10 plus 2 level computer science teacher was so good that he intrigued interest in me, and that is why I pursued computer science as a career path. Okay, so I'm not sure how many of you has the same level of interest right now in computer science. You may have just joined the institute because you had a certain rank and someone told you triple IT Lucknow is good, so you just joined, right? You may not have any interest in computer science before that. So my job is also in some ways to intrigue you, right? To study more computer science, and all those additional readings and homeworks that I give you, that is mostly to intrigue your mind, right? And the same thing is there with data structures. You will study data structures at depth in the next semester, something like that. But the idea was just to give you a brief. Nihal, I don't know whether I will be there in the next semester or not. So the only thing I can tell you is, like, I'm trying to teach you so many things right now because the only thing I am sure about is this semester that I am here. Um, so I don't know who will be the teacher in the next semester. So, but the idea is, if you guys have interest, okay, if you guys have developed interest in computer science. This happened with me in my B.Tech. I used to study everything before the teacher taught us, right? Because not because I was some kind of a geek who wanted to study everything. It's because I had interest. I never studied, for example, non-computer science subjects. I struggled in the non-computer science subjects, in professional communication and economics and organizational behavior. All those subjects in B.Tech I really struggled with because I had no interest studying them. Okay, but with computer science subjects I used to study everything beforehand, not because I was a geek, because I was really interested. Like, for instance, some of you might today be so excited that, okay, there is something called stack and there is something called queue. Why do I need stack and queue? Why only why can't we do everything just with arrays? Okay, so then you can probably go to the Wikipedia page of stack and queue and study, and then you'll understand, oh, this is the reason why stacks are there. This is the reason why queues are there. Okay, I'm just like giving you a simple analogy that if you actually have intrigued in computer science, this is why I I actually taught you some things on certain things on assembly language. So now when you start studying computer organization, all those dots will connect. Okay, now you will understand why why do you have these things in the multiples of 2, because when you have three physical lines, you can represent 8 states out of it, or when you have 4 physical lines, you can represent 16 states from it. Similarly, when you study operating systems, you will know, okay, so this is what happens when I run when I run a program. It becomes a process, and that process has to be allocated memory in the main memory, and so things like this, right? So the idea is, I'm just touching up upon all these concepts, um, because I feel it might intrigue you to study more computer science. Okay, from there onwards you are on your own. Okay, so my job is kind of done after this semester. If even half of the class has become self motivated to study computer science, then you won't study, you won't struggle. Okay, there are enough resources on the internet these days that you don't even need a teacher. You can actually start studying on your own. Okay, so again, coming back to today's lecture, so this stack and queue thing, it's not something that you have to be very thorough with. Okay, even if there are confusions, it's fine, right? Maybe the confusions are good. It will keep you motivated to study, right? But don't the idea is you should understand that there are certain things like stacks and queues, and I'll also cover up linked list in the next week. So when you go to the next semester, whomsoever teaches you data structures, you'll be probably a little bit ahead, and you can study and understand all these things. Okay guys, we have hit the 11 a.m. and please respond to Tia's forms.
Sir,
Go ahead.
sir, my question was that if I take an array of 5 size
Mhm.
and particularly I give the value of like I have taken array of name ARR. So I have
Mhm.
given ARR. After that, if I use pushback, will it allocate to ARR3 or will it not work?
See, it's like this. You can, because see, stacks and queues are something that you are building on top of an array. Okay, so your compiler will have no problems if you do something like ARR2 equal to something. Okay, the idea is you are implementing code for some application where these values, okay, the inserted values or the deleted values are going to come through user inputs. Okay, so if you go back to our insertion and deletion uh, program, right, basic array operations, what did we require? So when I say if I want to do insertion,
Sir,
I give two inputs. Yeah, go ahead.
so like in the example in NQ, I we can do the thing which I have said, but I have all the example which I have seen till now about pushback. Every value starts from index 0.
Yes,
So I
and that
have
is right.
not
It has to start.
seen.
That is the idea. That is the idea. It has to start from index 0. Okay. um, this is what I'm saying, that basically you are using an array to emulate a stack. Okay, so certain operations on array are restricted as in it is not restricted by the compiler, you are restricting it. So let me give you this example. You saw that basic array operations program where we were doing two operations, insertion and deletion. And when if the user said I want to do insertion, I asked for two inputs, right? The value to be inserted and the index to be inserted. Now just assume if I do not give user that option, I say, okay, what value do you want to insert? User says 10, but I don't ask for the index. Okay, I said index will be decided by me. I will make sure that whatever you insert, it goes to the end of the array. You do not have access to my arrays indices. I will decide where the new value will go. You understand that
Yes,
I
sir.
have restricted the insertion to only the end of the array. Of course, at the code level I can always do arr I equal to 5, but now I'm writing a program and I say I'm implementing a stack. So no, the only operation that user has, okay, the user can only say push 20. Okay, user cannot say push 20 comma 5. So, user cannot say please insert 20 at location 5. No, that I will not accept. I will only accept, okay, tell me what you want to push, I will push it in the array. Okay, so this is the idea. This is why I start with index 0. In the beginning my stack is empty. Okay, my tumbler is empty, there is no biscuit in the tumbler. So if I add a biscuit to the tumbler, it cannot hang in the air at location 3, it will go down to location 0. That is the idea. Okay, so I am using arrays to implement a higher level entity, and that higher level entity is stack.
Okay, sir. Thank you, sir.
Okay, and as I said, don't be too worried. You are going to study all these things when you study data structure. Some of you may have this doubt that why do I even need a stack? I can array, I can access anything from anywhere. But this is the idea, having a data structure which is restricted, it has advantages. Okay, you will understand these advantages when you study more computer science. That is the idea. Okay. Okay, guys. So we are already 5 minutes late. Let's decide upon the lab thing. Some of you have genuine concerns. I have seen the responses, and all of you who have genuine concerns, I'll have a meeting with you. at the end, but please fill the form. Okay, even if you don't find any of the slots applicable to you, please fill the form and write the reason that why are these slots not applicable to you. I will have a meeting with all of you towards the end so that we can find a solution for your case as well. So for instance, one student has written that she cannot have access to internet inside her house, so she goes to some other place, and if we put the lab in night, she won't be able to do it. So things like this, we will address all those issues, but please fill up the form. Okay, thank you guys, bye.